Good morning. We will start session 6 on pair of linear equation in two variables. So till now we have completed graphical method, and under algebraic method we completed substitution, elimination, cross multiplication, and this is the last method, that is equations reducible to pair of linear equations in two variables. Where a given pair of equations we have to reduce that in the form of linear equation form and then solve it. So this is the last exercise. After this we have an optional exercise which we will also be solving in the next session onwards. So first one, 1 upon 2x plus 1 upon 3y is equal to 2, and the second one is 1 by 3x plus 1 by 2y is equal to 13 by 6. Now how to understand that whether the given question is relating to equations reducible to linear equation form? When you look at the sum, you will understand this is not in the correct format of a linear equation. How a linear equation has to be? A linear equation, when we write, the x and y variable should always be in the numerator. If you recall in the previous few sums, we had this type of a sum where we took LCM and we solved, correct? But the variables were there in the numerator, not in the denominator. So to understand that, it is a form of an equation reducible to pair of linear equation form means in such type of sums, the variables are always in the denominator. Okay, that is the hint. When you look at a particular sum which tells that denominators have variables, that means we have to reduce them and form linear equation pairs. Let's start. So whenever we have this type of thing, we will assume that leave the coefficient, only consider the variable. 1 by x is equal to, we have to consider this 1 by x is equal to some different variable. That can be x, that can be a, that can be u, or anything. Usually some books, if you refer, you have x and y, capital X and capital Y. Some books they give capital A and capital B. Some books give U and V. So what I have seen in majority all the schools and in some of the NCERT books, they usually prefer U and V. Let's go with U and V. There is no hard and fast rule, children. You can choose any of the variable, but stick to one what you are using. Do not use the same letters again. That leads to a confusion. So I will be going with U and V. Let 1 by x is equal to u. Please differentiate between your u and v. V is written like this, u is written like this. If you write like this, both are neither u or neither v. So learn to differentiate between your u and v. Okay. Let 1 by x is equal to u and 1 by y is equal to v. Now wherever we have x and y in terms of 1 upon, let us substitute. This equation, 2 will remain in the denominator only. We are only bothered about variables. 1 by x is u, so this will be, first equation will be u upon 2 plus this will be v upon 3, because if I close this, what will remain? 1 by y, that is v. If I close this, it will remain 1 by x, which is nothing but u, is equal to 2. So now we know that we can take LCM and we can solve as we have done earlier. LCM of this 2 is 6. So into 3 into 2. So this is 3u plus 2v is equal to 2. So I can say this as 3u plus 2v is equal to 12 is your first equation. Okay. So we arrived at the first equation here. Next, we'll solve for this also. This will be written as, I'll be solving it here. This is 1, this is u upon 3 plus v upon 2 is equal to 13 upon 6. LCM is 6 into 2 into 3. So this is 2u plus 3v is equal to 13 upon 6. So 6 and 6 will get cancelled. 2u plus 3v is equal to, we will name this as equation 1, children. This as equation 2, because that's a given equation. This as equation 3 and is equal to 13 as equation 4. Right? Look at this. We have reduced the given pair of linear equation to, we have reduced them to the linear equation form. Now we know how we have to solve it. How do you solve it? It's left to you. Whether you want substitution method or elimination method, I'll leave it to you. I will usually go for elimination method. Solve equation 3 and 4. How do we solve this equation now? Let us look at the terms given. 3u plus 2v is equal to 12 and 2u plus 3v is equal to 13. Decide which u or v you want to eliminate. Based on that, let us multiply. I will eliminate u term, so I multiply this by 2 and this by 3. So this is 2 3s are 6u plus 2 2s are 4v is equal to 24 and 3 2s are 6u plus 9v is equal to 13 3s are 39. Let us subtract the given equation by changing the sign. 6u and 6u will get cancelled. 9 minus 4, that is minus sign is for the 9, so minus 5v is equal to 39 minus 24. 9 minus 4 is 5, 3 minus 2 is 1, minus 15. So v is equal to 15 upon 5 is minus minus cancel plus 3. v is equal to 3. Now this is not the final equation. We have to find x and y, that is original x and y. Find u. Substitute v is equal to 3 in equation, which equation? Either 3 or 4. We'll use equation 3, which is 3u plus 2v is equal to 12. 3u plus 2 into 3 is equal to 12. 3u is equal to 12. 2 3s are 6. 3u is equal to 6. U is equal to 2. We found out the value. The sum still continues, children. We found out the value of u and v now. Now, we had taken something here. Therefore, 1 upon x is equal to u. So, keep that x as it is. 1 upon x is equal to u value is 2. This implies reciprocal if I take x is equal to 1 by 2. Okay. Similarly, we try the y value. 1 upon y is equal to v. 1 upon y, v value is 3. So, reciprocal if I take y is equal to 1 by 3. These are my final answers. So, understood how did we solve this? Whatever equation we equate, first we have to find that and then substitute that in the original equation. I just gave that as equation 1 and 2 because that is our original given equation. Then we equated them into by reducing them to a pair of linear equation form. Used elimination method to find it, and this is how we are going to find the sums. So, I am giving 2 homeworks here. First one I have done, anyhow, second one I'll finish and then I'll mark for homework. So, second one, there is a root sum, a similar method we have to approach it to that also. Let's start with the second sum quickly. So, in exam, they will not tell you you have to use it by pair of linear, reducing to pair of linear equation form. But looking at the question, you have to understand this given sum can only be solved by reducing it to pair of linear equation. The hint is variables will be in the denominator. With that being identified. Look at the second one also. First mean Second one, 2 upon root x plus 3 upon root y is equal to 2. And the next equation is 4 upon root x minus 9 upon root y is equal to minus 1. So this is my equation 1 and this is my equation 2. Why? Because it's a given equation, original one. So we'll check the equation. 2 by root x plus 3 by root y is equal to 2. 4 by root x minus 9 by root y is equal to minus 1. Solution. Let 1 by root x is equal to u and 1 by root y is equal to v. Again, so 1 by root x is equal to u, 2 in the numerator as it is, 2u plus 3v is equal to 2. Only if you have even though coefficients here denominator, it will come as a fraction. Otherwise, it will come directly straight equation here. Equation 3. Next one. Here if I name this 4u minus 9v is equal to minus 1, equation 4. Directly. So let's solve equation 1 and 2. Solve equations 1 and 2. 2u plus 3v is equal to 2. 4u minus 9v is equal to minus 1. So anyway, how we have 1 plus and 1 minus, let us eliminate v term here by multiplying this by 3 and this by 1. So that we can only get this as 9. Anyways, we have 9 here. So 3 2s are 6 plus 9v is equal to 3 2s are 6. So same as it is, 4u minus 9v is equal to minus 1. You are going to add the equation because we already have opposite signs. Plus 9v minus 9v, 6 plus 4, 10u, 6 minus 1, 5. Therefore, u is equal to 5 by 10. Don't write 5 by 10 as again 2 because 5 divided by 10. 5 1s are 5 2s are. U is equal to 1 by 2. So we got u value. You do this one below the other children. Substitute. U is equal to 1 by 2 in equation. I think third equation is very simple. We'll substitute. 2u plus 3v is equal to 2. 2 into 1 by 2 plus 3v is equal to 2. 2 and 2 cancel. 3v is equal to 2 minus 1. So v is equal to 2 minus 1 is 1 by 3. Right? So we got u is equal to 1 by 2 and v is equal to 1 by 3. Further, the sum continues. Look at the further part here. I do it here, children. So what we have considered? Therefore, 1 by root x is equal to u. So 1 by root x is equal to, what is u value? 1 by 2. So 1 by 2, 1 by root x. So directly we can say that root x is equal to 2. Squaring on both sides. If you square on both sides, square and root will get cancelled. 2 square, or simple, when a square root transposes to other side, that becomes square. That way also you can say. So x is equal to 4. Similarly, 1 by root y is equal to v. So 1 by root y is equal to 1 by 3. Root y is equal to 3. I will just write now y is equal to 9. Systematically, if you go on solving, you will get it. This is the way how you have to solve. So I am marking this third one for homework. Look at the third one, children. 4 by x plus 3y is equal to 14. 3 by x minus 4y is equal to 23. Now what they have done here is, value, y term they have given correctly because it is in numerator. Only thing what we have to do is substitute for x part only, not for the y. So only for the x part you substitute, find the value of x and do it, you will get this. Why you need not do? Why? Because as it is you will get it there only. Okay. I will start with the next is sixth one. I want, okay, sixth one we will do because sixth one again is different from seventh and eighth. So not sixth one, sorry, fourth one we will do it here. Third one you can mark it for homework. I will write the homework sum now then. So you have two homeworks in this main. So that is from first main I will give you third one as homework and I will also give you seventh one as homework. Okay. So these two are your homeworks. Remaining sums will be solving here. Okay. Fourth one, 5 upon x minus 1 plus 1 upon y minus 2 is equal to 2 and 6 upon x minus 1 minus 3 upon y minus 2 is equal to 1. Yes, a question might arise in your mind saying that look at this sum. It is in the form of a denominator x minus 1 y minus 2. Here also x minus 1 y minus 2. Teacher, what if we give here also x minus 2? Then what we should do? Then the question is wrong. They can't give different types of variable combination in this sum. They have to give you the same type. If you get this type of a question, of course the question given is wrong. So this has to be x minus 1 only. Whatever variable form you have here in first equation, the same variable form should be given in the second equation also. In case it is different, then it is an incorrect question. So, this is your equation 1 and this is your equation 2. Let 1 upon x minus 1 is equal to u and 1 upon y minus 2 is equal to v. Now we know what to do. Directly we get it here. So, this is 5u plus v is equal to 2, equation 3. And I'll write next equation here only. Next equation is 6u minus 3v is equal to 1, equation 4. Correct? 5u plus v is equal to 2. 6u minus 3v is equal to 1. We have 1 plus 1 minus. Easy for us. So let us cancel v term and multiplying this by 3 and this by 1. 3 5s are 15u plus 3v is equal to 3 2s are 6 into 1. 6u minus 3v is equal to 1 as it is. You are actually adding the equation here. Plus 3v minus 3v will get cancelled. 21u is equal to 7. U is equal to 7 upon 21. U is equal to 1 by 3. Okay. So, substitute. U is equal to 1 by 3 in equation. Shall we take first one? Okay. No, sorry. Third one. In equation 3. Okay, we'll do it here. 5u plus v is equal to 2. 5 into 1 by 3 plus v is equal to 2. V is equal to 2 minus 5 by 3. If you take LCM, v is equal to 6 minus 5 by 3. V is also equal to 1 by 3. Now we have u and v values. Let us find out. Therefore, 1 upon x minus 1 is equal to u. So 1 upon x minus 1 is equal to 1 upon 3. X minus 1 is equal to 3. X is equal to 3 plus 1. X is equal to 4. Okay. Next, what value we have to find? We have to find for y. 1 upon y minus 2 is equal to v. 1 upon y minus 2 is equal to v is also equal to 1 by 3. Y minus 2 is equal to 3. Y is equal to 3 plus 2 and y is equal to 5. X is equal to 4 and y is equal to 5. We are getting it actually very easily. Only thing you should know how to start with it and substitute the given value. Yes, quickly we'll start with the fifth one. Let us see fifth one. Again it's the same thing, but since denominator is a bit different, so let's understand how to solve fifth one also. You will get an idea what type of a given sum depending on the numerator, depending on the denominators, how to start with it. Okay. Fifth one, which is 7x minus 2y divided by xy is equal to 5 and 8x plus 7y divided by xy is equal to 15. Okay. 7x minus 2y divided by xy is equal to 5. 8x plus 7y by xy is equal to 15. Let us split the denominators for each fraction if you want to write it. This is your original equation 1 and 2 given. I will write this as 7x upon xy minus 2y upon xy is equal to 5. X and x will go, y and y will go. What will remain? 7 upon y minus 2 upon x is equal to 5. Is this of the equation reducible to pair of linear equation form again? Yes. Similarly, we will get this one also. 8x upon xy plus 7y upon xy is equal to 15. X and x, y and y. So this is 8 upon y plus 7 upon x is equal to 15. We originally got the equation. They have given y as first and x as. Let's start accordingly how it is. Let 1 upon y is equal to u and 1 upon x is equal to v. It's up to you. You can also take this as v and u, however you feel like. Let us substitute. 7u minus 2v is equal to 5 and 8u minus 7v is equal to 15. So it's better if you substitute this. It is much easy. Minus sign is there. You can change the sign later. Or again multiply this by 8 and multiply this by 7. Let me check with the equation. Oh, I changed the sign. I'm sorry. It is 8u plus 7v. Yeah. So let's go with this only because we have 1 plus and 1 minus. So this is my equation 3 and this is my equation 4, where I can multiply this by 7 and multiply this by 2. Okay. 7 sevens are 49u minus 7 twos are 14v, 7 fives are 35. So 8 twos are 16u minus 7 twos are plus 14v, 15 twos are 30. You are actually adding the equation. So 14 and 14 will get cancelled. 49 plus 16. So 9 plus this is 15. 4, 5, 6. 65u is equal to 65. Oh. So u is equal to 1. So since u is 1, what we can do here is Which question it is? Fifth one, right? Okay. Since u is 1, substitute u is equal to 1 in equation 3. 7u minus 2v is equal to 15. So 7 into 1 minus 2v is equal to 15. So minus 2v is equal to 15 minus 7 minus 2v is equal to okay. So minus 2v is equal to 1 second children. 7u minus 2v is 5. We have taken 15. Okay. So 7 first third equation is 5. I have taken this equation value here. Minus 2v is equal to, so 5 minus 7 minus 2v is equal to minus 2. So v is also equal to 1. U is also equal to 1. V is also equal to 1. And our last part now. What is that last here? Therefore 1 by y is equal to u. So 1 by y is equal to, what is u value? 1. Doesn't matter, any reciprocal or something. Y is equal to 1 and 1 by x is equal to v. So 1 by x is equal to 1. Therefore x value is also 1. Y value is also 1 here. So we got both x is equal to 1 and y is equal to 1. Sixth one sum is again the same as the previous one, but it looks different here. So previous sum we had this xy in the denominator both the sides. Now we have that on our RHS side. So original given equation. I'll be giving this for homework children. I'll make this as sixth one and seventh one. I'll show you what you will do and then I'll give this for homework. So what I'll do here is now 6x plus 3y is equal to 6 divided by xy and 2x plus 4y is equal to 5 and divided by xy. Further, I will not tell you what to do. You all know it better. What will you do here is same old method what you can do, right? This equation can also be rewritten as, you can take 3 common. So 3 2s are 6. 3 1s are y. So 3 2s are 6 divided by xy. This one you can rewrite if you want. If you take 3 common, 3 2s are 6, 3 1s are 3 divided by 3, 3 2s are 6. And the same there. So I am giving this sum for the homework again. You know what to do for the 3 sums homework, that is 3rd, 6th and 7th one. I will be doing the last one, that is 8th one here. So you can make a note of this and start further. We'll quickly begin with the 8th sum because 7th sum is similar to 8th one. So if I do 8th one, you will understand the 7th sum also. 8th one is 1 upon 3x plus y plus 1 upon 3x minus y is equal to 4 and the second is equal to 3 by 4. And the second set of equation is 1 upon 3x plus y of 2 minus 1 upon 3x minus y of 2 is equal to minus 1 by 8. Check with the equation. 1 upon 3x plus y plus 1 upon 3x minus y is equal to 3 by 4. 1 upon 2 of 3x plus y minus 1 upon 2 of 3x minus y is equal to 1 by 8. Original equation 1 and original equation 2. Solution. Let 1 upon 3x plus y is equal to u and 1 upon 3x minus y is equal to v. So directly if I have to say this one here is, first equation will be, everything is 1 upon, yes. So this is u plus v is equal to 3 by 4, and next is, it is not directly u minus v, 1 upon 2 is there. 1 upon 2u plus minus 1 upon 2v is equal to minus 1 by 8. This is equation 3. What we can do here, since we have 2 in the denominator, we can just take LCM, make it very simple. U minus v is equal to minus 1 by 8. 2 ones are, 2 fours are. So u minus v is equal to minus 1 by 4 is my next equation. Okay, let's solve this. U plus v is equal to 3 by 4. U minus v is equal to minus 1 by 4. So when you add, so we cancel v and v. U plus u is 2u is equal to 3/4 minus 1/4 is half. I'll continue here. So this will be written as u is equal to now 1 by 2 into 2. So this 2 comes down. So u is equal to 1 by 4. Substitute. U is equal to 1 by 4 in equation. Which equation would you like to do that? In equation 3. Or, okay, any equation. In equation 3. U plus v is equal to 3/4. So u is 1/4 plus v is equal to 3/4. V is equal to 3/4 minus 1/4. So 3/4 minus 1/4 is half. Now v is half, right? So still the question continues, and we'll be doing it wherever the space is available here. Okay, so we got u and we got v value. Now substitute. Therefore, 1 upon 3x plus y is equal to u. So 1 upon 3x plus y is equal to, u is what? 1 by 4. This implies 3x plus y is equal to 4. Which equation? Equation 5. Next, 1 upon 3x minus y is equal to v. 1 upon 3x minus y is equal to 1 by 2. So 3x minus y is equal to 2. Equation 5. Now children, what is this? Again pair of linear equation. Solve it. 3x plus y is equal to 4. 3x minus y is equal to 2. You actually add them. So 3x plus 3x, 6x is equal to 6. X is equal to 1. Final value. Okay. Substitute. X is equal to 1. In equation, which equation? Either 4 or 5 only you have to substitute. In equation 5. What is 5 equation? 3x plus y is equal to 4. I started the sum here. U value, then again further value. The last part, x is equal to 1. 3 into 1 plus y is equal to 4. Y is equal to 4 minus 3, y is equal to 1. So x is equal to 1 and y is also equal to 1. So in this question, you got a pair of linear equation. After putting u and v value, you again got a pair of linear equation, which you solve it again, you get x and y value. So some are quite lengthy and some are quite similar. So this is how you reduce it to pair of linear equation form. So this has to go one below the other neatly. So we'll quickly start with the verbal questions. Now again the verbal questions, as you know, I will only get you the algebraic equation. Further solve it by any of your convenient method. The first one. These are very important sums where it comes to upstream and downstream sums. You have some more extra sums given in worked examples. Also, we have them in next quadratic equations. Ritu can row downstream 20 km in 2 hours and upstream 4 km in 2 hours. Find her speed of rowing in still water and speed of current. So, we have speed of rowing in still water as well as in current. Speed of current what we have to find in water as well as in current. So let us assume that, which is this second thing, first one, let the speed of rowing in still water be x kilometer per hour, because speed is given in terms of kilometer per hour, and speed of rowing in still water be x kilometer per hour, and in speed of rowing in still water be and in current, and the speed in current be y kilometer per hour. So we understood the speed of water, speed of rowing in still water, and in current be x and y kilometer per hour respectively. So whenever we talk about upstream and downstream, downstream when we say it's always plus and upstream is always minus. So speed, what they have given here is upstream and downstream, right? Speed of rowing upstream and speed of rowing downstream. So upstream when we consider it is x minus y kilometer per hour, and downstream is x plus y kilometer per hour. These type of sums, there are starting several steps which are to be same to be written always, looking at the given situation. Okay. So now we have understood about speed what we have written. We know that always in the speed type of a sum, always we should know the physics formula what we use. Speed is equal to distance traveled upon time taken. This is what you have to know, and we are applying the same thing here also. Okay, now read the question. Ritu can row downstream in 20 km per hour. So, in case, or what we will write here is distance, or Ritu can row downstream, or simply we will write in case when she goes, downstream. Okay, in case when she goes downstream, so what is the speed what we have to calculate here? Okay, in case when she goes downstream, read that here. What is that downstream? How much kilometer? In case if she goes downstream as 20 kilometer in 2 hours. Okay, how do we equate this equation? Now she is going downstream 20 kilometer in 2 hours. That means distance is 20 kilometer, time is 2 hours. Since she is going downstream, it is x plus y. So can I write this as speed into time? If I consider x plus y into 2 is equal to downstream 20 kilometer distance in 2 hours, that is time where the speed is x plus y. So distance is equal to speed into time. I have done, right? So multiply this equation, or you can just bring this 2 down. So this can be written as x plus y is equal to 10, equation 1. Okay. Next case, in case when she goes upstream, okay, how much does she goes upstream? Let us see here. In case and upstream 4 kilometers. Time taken is in how many hours they have given? Okay, this is also 2 hours. In 2 hours. How do we represent? It is upstream. So this is x minus y. So time taken is 2. Distance traveled is 4. We wrote it. So x minus y is equal to 2 comes down. So this is 2. Equation 2. Now you have equation 1 and equation 2. With this, can you find the value of x and y? That is speed of the rowing in still water, what you can get, and speed of the current in still water, what you can get it as y. That is how you find x and y separately, right? So I have arrived till the algebraic equation. Further, eliminating it and finding, it's up to you. And find the value of x and y and please give the concluding answer. We'll quickly start with the next one. So, second one, 2 women and 5 men can together finish an embroidery work in 4 days, while 3 women and 6 men can finish it in 3 days. Find the time taken by 1 woman alone to finish the work and also that of 1 man alone. Now, always remember, when it comes to number of days when they are working it or combining it, it's always considered as 1 day as 24 hours or 1 upon whatever number of days we consider. Since these type of sums, you'll understand when I am solving it. 2 women and 5 men can together finish an embroidery work in 4 days. So first of all, let us understand that let time taken by 1 woman to finish the work in x days and by 1 man in y days. That means by women we consider as x days and by 1 man we consider that as y days. Next, then according to that, they have given 2 women and 5 men on simultaneously. Let us understand that 1 woman's 1 day work is given by 1 by x. Why 1 by x? 1 day, 1 whole day, 24 hours what we consider. It's always taken as 1 by x. So if 1 woman's 1 day work is considered as 1 by x, simultaneously how many women we have? 2 women we have. That means even 1 man's, right? 1 man's 1 day work is given as 1 by y. So now we understood that 1 woman's 1 day work is given by 1 by x and 1 man's 1 day work is given by 1 by y. Read the question. 2 women and 5 men together can finish by data. If 1 woman can finish in 1 by x, then 2 women can finish in how many days? Depending upon that, what we write here is, so by data, 2 women, that is 2 by x plus and 5 men, 5 by y, together they can finish the embroidery work in 4 days. Now 4 days when we write, it is considered as 1 by 4. Why 1 by 4? 4 days of work, 24 hours in a day. So with respect to 1 day we consider that. So it is 1 by 4. So this is our first equation. Let us first simplify this first equation, how it comes. So what do we do with this now? 2 by x and 5 by y. What format is? Denominators has variables. So what you should do? Since denominators are there, variables are in the form of denominators, reduce it to the pair of linear equation form. 1 by x is equal to so and so, 1 by y, right? Equation 1 and 2. You know how to solve this. What is the next equation? Just see here. While 3 women, 3 by x plus 6 men, 6 by y can finish a piece of given work in 3 days. 1 by 3. Equation 2. So we have equation 1 and equation 2. Equation 1, yes. You know how to solve this now? Both the equation, let 1 by x is equal to u and 1 by y is equal to v. Find the value of u and v, substitute that and find the value of x and y. That will give you 1 woman's and 1 man's work. So this is how you solve it. Since you got the equation in this form, you have to solve it, reducing them to pair of linear equation forms only. And the last one. Ruhi travels 300 km to her home partly by train and partly by bus. She takes 4 hours if she travels 60 km by train and she takes 10 minutes longer. 60 km by train and remaining by bus. If she travels 100 km by train and remaining by bus, she takes 10 minutes longer. So they have two different equations given to us and two different conditions how she travels. Find the speed of the train and speed of the bus separately. So first two equation should be, let the speed of the train be x kilometer per hour and speed of the bus be y kilometer per hour. Okay. Let us keep by as it is. So, distance travelled or we write total distance travelled by Ruhi first. That's the first one what they have given. Total distance travelled by Ruhi. How much? 300 km. Keep this as it is. Case 1. Case 1 is she travels some part by bus and some part by train. They have given an equation and again by different. Let's see that. So she takes 4 hours if she travels 60 km by train and remaining by bus. Case 1. Distance travelled by, first is train, right? Yes. By train is equal to 60 kilometer. Okay. Now, if she is traveling 60 kilometer by train, then distance travelled by bus will be how much? By bus will be 300 minus 60. That is equal to 240 kilometer. This is by bus. Time taken. Total time taken. How much time does she take? 4 hours. To travel, to reach her house 300 kilometer. If Ruhi travels by train 60 kilometer and the remaining by bus, that is 300 total minus 60 is 240 kilometer. Then total time taken to travel this journey is 4 hours. We know that. What do we know? Speed is equal to distance by time. Keep this as it is. We are going to apply this for both the equation. Speed is equal to distance upon time. Now what all we know here? We know speed. Do we know distance? Yes. Do we know time? Yes. So how do we apply this now? Now first of all, let us bring this equation as time is equal to distance by speed, because she is travelling some part by train and some part by bus. By data, if I say she is travelling, what is this? Train is 60 km per hour. What is the speed of the train considered? X plus. Then she is travelling 240 kilometers by 240 upon y is equal to 4 hours. Can I write this 4 is equal 4 equally here? What is this? Speed upon what I have written, or what is this? Distance upon speed I have written. The speed I have taken here. Okay, I'll write it if you want here. So distance upon speed I have given equal to time. So this formula I have applied, that is by data. 60 upon x plus 240 upon y is equal to 4. Now what is this form of pair of linear equation reducing to this form? But still, can you see that something is common between 60, 240 and 4? Let's take that. So what we will do is here, I will take 60 common. So if I take 60 common here, what will remain? 1 upon x plus 60 common. So this is 4. 60 into 4 is 240. 4 by y. So here it will become 4 upon 60. 4 ones are 4 15s are equation 1. Isn't this equation very simple than this to solve? See what simple I did was here, I took 60 common. So 60 ones are 64s are. If I take 60, see children, like this it is. If you take 60 common here, right, 240 is equal to the 60 will come down. If this 60 will come down here, in the next equation it will be written as 1 upon x plus 4 upon y is equal to 4 by 60, 4 ones are 4 15s are. 1 by 15 is your first equation. Okay, so we got that now. 1 by x okay, and the next equation let us see now. Case 2, shall I write here children? Okay. So in case 2, I will directly write by train and you have to write the statement. I don't have a place there. Distance travelled by train. How much distance she travels by train? If she travels 100 km by train. So this is 100 km. Then by bus it will be how much? So this will be 300 minus 100, that is 200 km. Time taken is how much? Time taken is 10 minutes longer. So this is 4 hours 10 minutes. How to write this 10 minutes in terms of hour? 1 hour is equal to 60 minutes. So 10 minutes is equal to how many hour? 10 by 60 hour. So this is 1 by 6 hour. So 1 by 6 hour can be written as 4 1 by 6 hour, which is nothing but 6 4s are 24. 24 plus 1, 25 by 6 hour. Okay. By data, we will write here a complete statement. By data. Same distance by speed if I apply 100 upon x plus 200 upon y is equal to 25 by 6. Now what I can take common? I'll take 100 common. 1 by x plus 2 by y is equal to 25 by 6. 1 by x plus 2 by y is equal to 25 by 6 into 100. 25 ones are 25 fours are 1 by 24. So what is the final equation here children? 1 by x plus 2 by y 24 is your second equation. Okay. So the equation is 1 by x plus 2 by y is equal to 1 by 24. So this part is not clearly visible. You understood here, right? 1 by x plus 2 by y is equal to 25 by 6 into 100. I will write here the equation neatly. 1 by x plus 2 by y is equal to 1 upon 24 is your second equation. Right? So we have equations 1 and 2 now. You know how to solve? By reducing them to pair of linear equation form. You will find x and y, which is nothing but speed of train and bus respectively. So with this we complete the chapter pair of linear equations in one variable. We complete the exercise given. So in our next session, that is tomorrow's session, we will be covering the optional exercise. So any doubt in today's class, you can call on the same day of the video set.